A very good afternoon to one and all. I am Dr.G.MURALIKRISHNAN, Associate Professor in the Department of EEE from S.A.ENGG College. Today, I would like to give a lecture topic on the GATE syllabus on KVL KCL, which comes under the section 2 in the GATE syllabus of electrical circuits. So first of all, before going for the KVL and KCL in detail, first of all we need to know what are the basic terminologies in the electric circuits. So we have some basic terminologies like network or circuit elements, third one which is a branch, fourth one it is about the node, fifth one what is a junction, sixth one what is a mesh, and seventh one what is a loop. So with the help of a circuit we can discuss those terminologies in detail. So this is termed as a electric network or circuit. So what is basically an electrical network? Any arrangement of various electrical energy sources along with the different circuit elements is termed as an electric network or electric circuit. What about the elements which are all connected to the network or circuit? They are termed as the network elements. So any individual circuit elements with two terminals, it may be a resistor, capacitor or inductor, can be connected with the circuit. They can be termed as a circuit element. So network elements can be either passive or active. So for example, I told just now resistor, inductor, capacitor, so they may be active as well as passive elements over there. So next to that, what is a branch? So part of the network which connects the various points with one another is called a branch. For example, in this, A to B, B to C, C to D, D to A, which can be termed as a branch. Similarly, we have your D to E, C to F, and E to F are also comes under your branch. What is a junction? A point where three or more elements meet is a junction. So point, if you consider point D and C where three elements are meeting, for example this element, and this element, so where three elements are meeting. Similarly, if you take the point C where R3, R2 as well as your R5, which are the elements connecting, so can be termed as a junction. What is a node? A point where two or more elements, where you consider point A, B, C, D, E, F, all can be termed as a node because it is need to satisfy at least two. Especially the C and D, they can be termed especially as node as well as junction. Especially they are termed as junction because three elements are meeting. So next to that, so two elements, more elements meet, can be termed as a node. So next to that, what is a mesh and loop? Sometimes most of the electrical engineers will term mesh as loop also, but there is a difference between mesh and loop. What is it? Basically, we will discuss loop. In that specific loop is termed as a mesh. First of all, we will discuss what is a loop. So a loop is a set of branch forming a closed path in such a way that one branch is removed, then remaining branches do not form a closed path. So it should to be a closed path. A mesh as well as will need to be a closed path only. So a loop can also be defined as a closed path which originates from a particular node and ending with that node itself without traveling through any other node twice. For example, if you consider A, B, C, D, A, it is a loop. Similarly, if you consider D, E, F as well as D, it is a loop. And if you consider your A, B, C, E, F, D, it is also a loop. But what is a mesh? A mesh is one which doesn't contains any other loop. So specifically the A, B, C, D, A, it is a loop. Similarly, loop as well as a mesh and similarly the DEFED, it is also a loop as well as a mesh, but specifically we can term those two as mesh alone. A, B, C, F, D, E, D, A, it is only a loop, it is not a mesh, because it is a combination of the previous two loops, so we cannot term that as a mesh. So next to that, source transformation. So we have two types of sources normally. So one, it will be the voltage source, another one it is a current source, because we require this thing so as to convert the voltage source to a current source and current source to a voltage source. So the basic behind this source transformation is the Ohm's law. So V equal to I into R, or I equal to your corresponding V by R. So here in this case, if you consider source connected to the source, current source, then just now I told, so V equal to I into R, similarly I equal to V by R. So we can convert a corresponding current source to voltage source, and likewise we can convert the voltage source to a current source. So we are going to discuss in detail about the KVL and KCL, and after that we get questions based on the KVL and KCL. So this is Kirchhoff's. After the Ohm's law, this Kirchhoff's law plays a major role in the analysis of electric circuits. So it was discovered by the German physicist in 1845 named Gustav Kirchhoff. Due to his name only this law came into existence as Kirchhoff's laws. He proposed two laws, one is the Kirchhoff's voltage law and current law. So these laws are generalized from the work of George Ohm, just now I told. So George Ohm, so he is the first who proposed it for the electric circuits, Ohm's law. After that, Kirchhoff's law. The laws can also be derived from the Maxwell's equation, but they were proposed later. So Kirchhoff's law, after the existence of Kirchhoff's law only, Maxwell's equations will come into existence, right? So next to that, what is Kirchhoff's current law? So at a node, the sum of incoming currents is equal to sum of outgoing currents. In simple form, we can tell it like that. So the total current flowing towards a junction point is equal to the total currents flowing away from the junction point. Or we can also propose it in another way. So the algebraic sum of all the currents meeting at a junction point is always 0. So the summation of all the currents at the junction point is equal to 0. So if you consider this one, so where two currents are entering and two currents are leaving. For example, the entering currents are your I1 and I2, and the leaving currents are your I3 and I4. So for example, if I consider my current I1, so I1 will be 2 amps, 4 amps, so the leaving currents, the summation will be equal to 0. The summation of all those currents, it will be equal to 0 at the junction. So this is regarding your Kirchhoff's current law. So next to that, so just now I told, right? So summation it will be 0. So next to that, it is your Kirchhoff's voltage law. So in this, we are considering in a closed path. So in any network, the algebraic sum of voltage drops across the circuit elements of any closed path is equal to the algebraic sum of EMFs in that path. So in a closed path, the sum of the voltages is equal to 0. Okay. So this is the thing regarding our Kirchhoff's voltage law, where the potential rise is equal to, so this is what we have just now I told. So the potential rise traveling from negative to positive marked terminal is termed as positive, and the potential drop traveling from positive to negative marked terminal must be negative. So this is regarding your Kirchhoff's voltage law. So I don't want to consume much time for the explanation of this thing. So directly we can move to the problems. So from the previous gate questions, so this question was asked in 2014. For the circuit shown below, compute the mesh currents. So here they have mentioned the meshes, so with the current representation as well as with their values. So here we have some 3 meshes, as well as they can be considered as loop. So I1, I2, I3. So what we have given some 4 options. So in that, the right option it will be A. If I tell like that, it won't be proceed, right? So we will see with the explanation. So we need to form three mesh equations. So from the previous diagram, so with a closed path, so we are deriving this one, which is the forming three mesh equations, and solving the above using your Cramer's rule, which is a basic thing that we have studied in our electric circuits in our second semester, most probably in all the universities as well as in all the colleges. So second semester. So from this, if you derive, the correct answers will be the option A, what I told just now. So regarding the current in the loop 1, it will be 5 amps, and regarding for current in the loop 2, it will be 3 amps, and in loop 3, it will be 2 amps. So the right option, it will be the first one, it will be here 5 amps, 3 amps, 2 amps. Like that only they can ask. So normally in our academic wise, we will compute only one current value. They will ask you questions like, but this is gate regarding, so they will ask you and they will twist you like this, and you need to mention what about the values. For example, the first one, it represents for 5 amps, it is for the first loop, and the second one, 3 amps, it represents for the second loop current, and the third one current, it represents for the third loop current. So next to that, we will discuss one more gate problem. So this question was asked in 2016. Use mesh analysis to find the current I0 in the circuit shown below. So where this is a current I0 which is present between these two loops. So this circuit is different from the previous one. So here this loop this circuit also has 3 loops. So I1, I2 and I3. And here the options, they are asking only one current value. Previously they have asked for 3 current values, right? So they have asked all the current, but here they are asking only one current value. The option, correct option, I know that. So which is 3 amps. So we will discuss that. So solution, so which is the difference of the current, because I0 equal to I1 difference with I2. It may be, it won't be I1 minus I2, because it maybe I2 or I1 will be a greater value, right? So we need to mention as difference of the currents only, because it is present between these two loops, that is between loop 1 and between loop 2. So that's why we are taking the difference of the currents between the loop 1 and 2. So we are applying here, as we have 3 loops here. So we need to derive the corresponding 3 loop equations and forming it in the Cramer's form and finding these currents. That is first current, which is 4.5 amps for the loop 1, and the second loop current, which is 1.5 amps, and the third loop current, which is 3 amps. That is, in the loop 1 it is 4.5 amps, right? For this one will be 1.5 amps, and this one it is 3 amps. So from this we are going to derive the corresponding difference of current. So which is the current, here it is where I, which is the current, which is your corresponding difference of the current we are taking. So here the difference, it is 4.5 and 1.5. So what is the difference? It is 3 amps. So the right option, just now I told, so the option C is the right option, which is 3 amps. I think you are clear with that. Next we will discuss one more thing, which is the third question, which was asked in 2017. So here they are asking, what about find the power supplied by 2 volt source. So here in this case, what about the power supplied by the 2 volt source? So we need to compute the power here by using this KVL, KCL. So the correct option, it will be 2 watts. So we will discuss that how it will be. So there are 3 meshes, right? So there are 3 meshes in this case, right? So 3 meshes are there. So 1, 2, 3, right? So 3 meshes are there, and we are deriving that one with respect to the mesh equations, and we are solving it. So what we are getting? We are getting a I1 equal to 2 amps, 1 amp. I1 equal to 1 amp. I2 equal to 5 amps. So what about the power supplied by the 2 volt they are asking. So if you know the corresponding current in the first loop, so the current into the corresponding resistance, right? So what about the current in the corresponding voltage, that will give you the power. This is a DC, right? So here if they sometimes they will ask you like this also, what is the corresponding current consumed by the power consumed by this 10 ohm also. But here the question they have asked this, they are asking only with respect to the voltage source. So we are concentrating only on the voltage source. So if you know the current and the corresponding voltage, we can tell what about the power. So the power here it will be 2 watts. So we will discuss one more gate question. So consider the circuit shown in the figure. Using mesh analysis, find the current supplied by the voltage source. Here previous case power, this problem is with respect to the voltage source. So we need to compute what about the corresponding current supplied by the voltage source. So here we have 2 sources, one is a current source, another one is a voltage source. Here they are clearly mentioned as voltage source. So we need to consider what is the current supplied by this 2 volt voltage source. So the right option for this one we need to compute. So regarding for the first option, right? So here the option is D. So we will discuss that. So mesh current are assigned as shown in the figure. So we are assigning the mesh equations, that is loop equations, as like what we have previously how we have derived. The same procedure we are deriving, and we are computing the corresponding current, which is the corresponding current is 0.1818, because the voltage source is present in the first loop itself. So regarding the current in the first loop, that will be the corresponding current supplied by that voltage source. So regarding here it will be 0.1818 amps. So they will twist you like this with the different values like a same representation, but you need to be very clear. The correct option is D. So with this I think you will be very familiar with the KVL, KCL, and we are discussing with respect to the problems based on the gate questions, previous gate questions. So these are the previous gate questions that they have asked, and we have discussed this. So I think I hope that you have well understood this topic, and if any other doubts if you are arising, so you can through the video once again, and you will get clarified, and we will see in the next session of a gate video class. Thank you. And I have represented with the, you can see it, I have mentioned the representation with the cock representation, because it is holding both things. So it won't get any electrical supply because it is holding in the same line. So it gets, the current won't pass through this animal, right? So most of you will have doubt on that. So how the crow is holding the element, the electrical wire, single electrical wire, because if it gets touched with another wire, then only the current will pass. Thank you.